Hello dear students, I welcome all of you in lecture first of course USMT 6A4 Numerical Analysis second elective paper A, unit first Interpolation. In today's lecture we study the first interpolation formula, that is forward difference formula. In this lecture we study first finite difference operators. For a function y is equal to f of x, it is given that y0, y1, up to so on, yn are the values of the variable y corresponding to the equidistant argument x0, x1 up to so on xn. These values x0, x1 up to so on xn, these values are equidistant. That means they lie in same distance. In between x0, x1 and x1, x2, there is a same distance, where x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, x3 is equal to x0 plus 3h, up to so on, xn is equal to x0 plus nh. That means x1 is h distance away from the x0, similarly x2 is a 2h distance away from x2 and h distance away from x1. Like this, the last point xn is n into h distance away from the x0. In this case, even though large and divided difference interpolation polynomial can be used for interpolation, some similar interpolation formulas can be derived. For this, we have to be familiar with some finite difference operators and finite differences which were introduced by Sir Isaac Newton. Finite differences deal with the change that takes place in the value of a function f of x due to finite change in x. Here, if there is a change in x, then there is a small change in f of x. Finite difference operators includes forward difference operator, backward difference operator, shift operator, central difference operator, and mean operator. In this lecture, we study only forward difference operator, which is known as delta. This is a forward difference operator. Denoted by the symbol delta. This is symbol pronounced as delta. Okay. For the values of y0, y1, up to so on yn of a function y is equal to f of x, for the equidistance values for the values y0, y1 up to so on yn of a function y is equal to f of x, for the equidistance values x0, x1, x2 up to so on xn, where x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, x3 is equal to x0 plus 3h up to so on xn is equal to x0 plus nh. The forward difference operator delta is defined on the function f of x as delta operates on f of xi is equal to f of xi plus h minus f of xi is equal to the same as f of xi plus 1, that is next point, xi plus 1 minus f of xi. Suppose I is equal to 2, then this formula is f delta f of x2 is equal to f of x2 x1 x2 plus h minus f of x2, like this, that is we get f of x3 minus f of x2. That is, we know that y is equal to f of x. Then this formula write like this, delta yi is equal to yi plus 1 minus y. This formula delta f of xi is same as delta yi. Then in particular, delta f of x0 is equal to f of x0 plus h minus f of x0, which is equal to f of x1 minus f of x0. This implies that delta y0 is equal to y1 minus y0. Okay. How do you understand? Suppose the line here is y0 here is y. Then we calculate delta x0 between f of x1 minus f of x0. This is difference between this y1 minus y0. This is known as difference operator, forward difference operator, or if this is our point H, here we get H value of y plus H. Therefore, delta f of x is equal to f of H minus F. This is the forward difference operator known as delta. Delta f of x is equal to f of x plus h minus f of x. This is the formula. Delta f of x1 is equal to f of x1 plus h minus f of x1 is equal to f of x2 minus f of x1. This implies that delta y1 is equal to y2 minus y1, etc. Delta y0, delta y1 up to so on delta yi are known as the first forward differences. Okay, second difference is calculated as follows. Delta square f of xi is equal to delta into delta. That is, delta square is written in the form of delta into delta. Delta operates on delta f of xy is equal to delta in bracket, first delta definition of delta, that is first difference operator, delta f of xi is equal to f of xi plus h minus f of xi, which is equal to then first delta operates on in bracket, delta taken in bracket, then we get delta f of xi plus h minus delta f of xi. Again, by using definition of forward difference operator, we get f of xi plus 2h minus f of xi plus h minus in bracket f of xi plus h minus f of xi, which is equal to f of xi plus 2h minus 2 f of xi plus h plus f of xi. In form of y, we write as y suffix I plus 2 minus 2y suffix I plus 1 plus yi. This is the second difference, second forward difference of f of xy. In particular, delta square f of x0 is equal to y2 minus 2y1 plus y0, or delta square y0 is equal to y2 minus 2y1 plus y0. Second difference. The third forward difference are delta cube operates on f of xi is equal to delta in bracket delta square operates on f of xy is equal to delta in bracket by definition of second difference operator. Here we use the formula of second difference operator, f of xi plus 2x minus 2 f of xi plus h plus f of xi. Again, operate this delta in bracket, we get yi plus 3 minus 3yi plus 2 plus 3 into yi plus 1 minus yi. In particular, delta cube f of x0, in particular delta cube f of x0 is equal to y3 in particular delta cube f of x0 is equal to y3 minus 3y2 plus 3y1 minus y0, or delta cube y0 is equal to y3 minus 3y2 plus 3y1 minus y0. In general, the n forward differences delta raised to n f of xi is equal to delta raised to n minus 1 f of xi plus h minus delta raised to n minus 1 f of xi. That means first delta is operator, and then operate second delta, third delta, and like this we operate delta raised to n minus 1 on the function f of xi. We get all differences. The differences delta y0, delta square y0, comma delta cube y0, up to so on, are called the leading differences. These differences are known as leading differences. Forward difference can be written in tabular form as follows. First column represents the values of x is value of x is x0, x1, x2, x3. Second column represents y, that is value of function at point x0, which is known represented by y0. Y0 is equal to f of x0, y1 is equal to f of x1, y2 is equal to f of x2, and y3 is equal to f of x3. This is the value of y at x3. Then we calculate first difference by notation delta y, which is equal to, by calculating the subtraction of y1 minus y0, delta y0 is equal to y1 minus y0. Similarly, delta y1 is equal to y2 minus y1, and delta y2 is equal to y3 minus y2. Subtract next term from the given term, that is y1 minus y0, y2 minus y1, y3 minus y2. Then we get first differences. Like this, we obtain second differences delta square y, which is delta square y0 is equal to delta y1 minus delta y0. Subtract delta y0 from delta y1, we get second difference. Like this, by subtracting delta y2, subtracting delta y1 from delta y2, we get second difference of delta square y1. Then we calculate third difference. Delta cube y0 is equal to delta square y1 minus delta square y0. Like this, we calculate n differences of the given function. we take one example. Example, construct the forward difference table for the following x values and its corresponding f values. Here we have given x and f. Values of x are 0.1, 0.3, 0.5, 0.7, 0.9, 1.1, 1.3. First we have to see that the values of x are equidistant or not. Here there is a difference between 2 points is 0.2. Therefore here is 0.2, difference is 0.2. These are 0.2. Similarly, this difference 0.2. 0.2. 0.2. Therefore, h equal to 0.2. And points are x, values of x are equidistant. Hence, we use the forward difference operator of this for this. Values of y, that is f, is given as 4.1, 0.003, 0.3, 4.3, 0.067, 4.5, 0.148, 4.0.7, value of f is 0.248, or value of x.9, value of f is 0.370, or value of x 1.1, we get value of f is 0.518, and for x is equal to 1.3, the value of f is 0.697. These are the given table. And now we construct the forward difference table for these values. First column contains the values of x, which is 0.1, 0.3, 0.5, 0.7, 0.9, 1.1 and 1.3. Second column contains the values of y, that is values of f, which is given 0.003, 0.067, 0.148, 0.248, 0.370, 0.518 and 0.697. First to calculate the first forward difference delta f by using the subtraction from 0.067 minus 0.00 is equal to 0.064. Like this, we take subtraction of one to next point. Then difference difference between these is 0.081, 0.100, 0.122, 0.148, 0.179. This is the difference. This is difference of 0.1, difference of 0.3. Like this we get the difference. Now we can take second difference and delta square f, which is same as we take subtract 0.064 from 0.081, we get 0.017. Subtract 0.081 from 0.100, we get 0.019. Similarly, 0.022, 0.0026, 0.031. Similarly, we take third difference, which is calculated by subtract 0.017 from 0.019, or by using formula f of x plus h minus f of x. Here this is f of x. And this is of with our formula delta f of x is equal to f of x plus h minus f of x, we get 0.03. Okay. Similarly, take next difference 0.03, 0.004, 0.005. And now we take fourth difference 0.001, 0.001, 0.001, and last difference is delta square of f is which is 0, that is constant. Fourth difference is constant. This table is known as forward difference table. If you have any query, example, construct the forward difference table where f of x is equal to 1 upon x and the values of x is going from 1, h is equal to 0.2 and last point is 2. Here we get four differences, forward difference. First we take the values of x, first column for the values of x. First value of x is 1, 1.0, next value is 1.2, next is 1.4, 1.6, 1.8, and last value is given which is equal to 2.0, that is 2. And value f of x is equal to function 1 upon x. Then using this function we calculate the values of y. First we put here 1 upon 1 is equal to 1. Now we take 1 upon 1, we get 0.833. We use the scientific calculator for this calculation, and calculator for this paper numerical analysis. I request all of you please buy scientific calculator and use check this calculation. Next value calculator calculating using this formula, f of x is equal to 1 upon x. Put x is equal to 1.4, we get 1 upon 1.4 is equal to 0.7143. Next value is calculated as 1 upon 1.6 is equal to 0.6250. Next value is 1 upon 1.8 is equal to 0.5556. Next value is 1 upon 2 is equal to 0.500. Now this is the values of and the values of y. Now you use the forward difference formula for this. Okay. By using delta f of x is equal to f of psi is equal to f of psi plus minus f of psi, that is subtract 1 from 0.833 we get minus 0.1667, subtract 0.8333 from 0.7143 we get minus 0.1990. Similarly, subtract 0.7143 from 0.6250 we get minus 0.08. Like this we get the difference as minus 0.0694 minus 0.0556. Second difference is calculated by using this formula. Subtract minus 0.1667, subtract minus 0.1667 from minus 0.1190 we get 0.0477. Similarly, the difference is 0.0297, actually 0.0199, 0.0138. The difference is minus 0.0180, minus 0.0098, minus 0.0061, and now fourth difference is 0.0082, and 0.0037 and last difference, this difference is minus 0.0045. Are you understand? The forward is table with WhatsApp or phone call. Construct the forward difference table for the data. Its values of x are -2024 and values of y is equal to f of x is 49722. The forward difference table is as follows: x -2024, value of y is 49722. The difference is calculated by 9 minus 4 is equal to 5, 17 minus 9 is equal to 8, and 22 minus 17 is equal to 5. Second difference is 8 minus 5 is equal to 3, 5 minus 8 is equal to minus 3, and last difference third difference delta qy is equal to 3 minus 3 minus 3 is equal to minus 6. This is the forward difference table for the given table. We study the property of forward delta. First, forward difference of a constant function is 0. First property for forward difference of a constant function is 0. Here our function is consider the constant function. From this now so because f of x is a constant function, therefore if you at some distance then we get same point k, therefore then by using formula delta f of x is equal to f of x plus h minus f of x is equal to k minus k is equal to 0. Our answer is k. Therefore first forward difference of constant function is okay. Second property, for the functions f of x and g of x, delta of x on f of x plus gx is the same as delta f of x plus delta gx. By definition, delta of x on f of x is equal to f of x plus x minus f of x. Using this definition, delta consider LHS. Consider LHS. LHS is equal to delta of x on f of x plus gx is equal to delta f of x on f plus g to take some main function f plus g on x using the formula f of x is equal to x we get f plus g of x on x plus h, f replaced by f plus g of x plus h minus f plus g of h, which is equal to f of x plus h plus g of x plus h. by using the definition of function. We separate the function by definition. F of x plus h plus g of x plus h minus f of x plus gx in bracket minus f of x plus gx, which is equal to f of x plus h minus f of x plus g of x plus h minus g of x, which is equal to delta, by definition, delta f of x plus delta gx. This is the proof of our second property. Proceeding as in second, for the constant a and b, delta of epsilon a into f of x plus b into g of x is same as a into delta f of x plus b into delta g of x. Forward difference of the product of the function is given by delta of epsilon f of x into g of x is equal to f of x plus h into delta gx plus g of x into delta f of x. This is the next line. Consider LHS. The LHS, which is equal to delta of epsilon f of x into g of x by using the definition of function delta of epsilon f into g of x, and which is equal to, by using the definition, by definition, delta of x is equal to f of x plus h minus f of is equal to f into g of epsilon x plus h minus f into g of epsilon x, which is equal to f of x plus h into f of x plus h minus f of x into g of x. Adding and subtracting f of x plus h into g of x in the above equation, above quantity, we get delta of epsilon f of x into g of x is equal to f of x plus h g of x plus h minus f of x plus h into g of x. Subtract this term and this term plus f of x plus h into g of x minus f of x into g of x is equal to f of x plus h into bracket, taking common f plus h is a common, we get is equal to f of x plus h in bracket g of x plus h minus gx plus the next term take g of x is common. Then we get in bracket f of x plus h minus f of x is equal to f of x plus, by formula this is equal to delta gx plus g of x, and by formula this is f of delta f of x. Therefore we get our required solution. Note, adding and subtracting g of x plus h f of x instead of f of x plus g of x plus h into g of x can also be proved that delta of epsilon f of x into g of x is equal to g of x plus h into delta f of x plus f of x into delta g of x. Now, for the functions is given by delta of epsilon f of x upon g of x is equal to q of x delta f of x minus f of x into delta g of x divided by g of x plus h into g of x. Proof. Delta of, consider LHS. Consider LHS. which is equal to delta of x on f of x upon g of x is equal to f of x plus h upon g of x plus h minus f of x upon g of x. By cross multiplication we get f of x plus h into g of x minus f of x into g of x plus h divided by g of x plus h into g of x is equal to f of x plus h into g of x minus f of x into g of x plus f of x into g of x minus f of x into g of x plus h divided by g of x plus h into g of x. Here in numerator and then subtract f of x into g of x in numerator we get here g of x is common. Therefore take gx outside from the bracket and in bracket what remaining f of x plus h minus f of x. Here we get x common minus f of x common, take minus f of x common, then we get in bracket g of x plus h minus g of x divided by g of x plus h into g of x. G of x by definition this is delta f of x minus f of x by definition this is delta g of x divided by g of x plus h into g of x. This is the solution of our property 3. So students, in this lecture we study the forward difference operator delta and its properties and construct forward difference table for the given data. In next lecture I will teach you the backward difference operator, which is called as delta operator. It is called as del operator. Forward difference operator is known as delta operator and backward difference operator is known as del operator. Okay. So student, thank you for watching this video. Thank you. If you have any query then ask me. Okay. Thank you very much.